Hello, everyone. Welcome to episode 46 of the Day Zero podcast. I'm Spectre. With me is Z. Before we jump into topics, I will be saying there is a new discussion video coming on Thursday. As some of you may know that have been watching for a little bit, we've been doing them bi-weekly. So that will be coming out on YouTube, which is also where you can find videos of our past podcasts and past discussion videos and streams and stuff like that we've done. I recommend anyone who enjoys the podcast to go and check it out. You can find the YouTube link just under the in the Twitch description. So today, some of the topics we'll be covering include the XP source leak, some Instagram bugs, and fault injecting Android with gaslighters, and a mixed bag of some other vulnerabilities and stuff like that. With that said, we'll jump right into the big fish, which is the Windows XP source leak. So it happened. I saw many people coming into the reverse engineering Discord and asking how to build it, because apparently it's not super easy to do. I think somebody actually figured out on 4chan that you have to change the date and time to be able to build the source files, which I thought was kind of interesting, but
Yeah,
I don't
that
know the specifics around it.
seems like an interesting requirement to change the timestamps on it. Do you know what the root cause of that was? I didn't really look into how to build it.
No, I want to say it was something with the build scripts. For some reason, something was dependent on the time, but I can't remember exactly what it was. So I can't speak too much on that. But one of the other things I saw kind of circulating around was a lot of people saying, "Oh, this is great. This is probably going to be able to help the React OS developers."
I think one of the
Yeah,
first
no.
comments here was actually a tweet at the React. At least I thought I saw that, but
Yeah, so I mean, here's the problem with that. A lot of people have been spouting that as if it's, something that you can totally do. Open source projects like React OS try to keep everything white room. And the reason for that is they don't want any leaked or illegal material touching their code base because it opens the door for some very messy legal water. And part of the reason I know this is from doing the PS4 toolchain, right? We stay very clear of using any like SDK, official SDK materials or any leaked information in the toolchain, because if it's found that there could be, the toolchain could be taken down or DMCA'd or whatever, which, would suck.
yeah, I
So
mean, the simple thing is that it is copyright material. So you can't just go and take the copyrighted code and plug it into your open source project.
yeah, I saw some people calling this open source, and I think that's where some of the misunderstanding comes into play. This is not open source. This is leaked source code. It is treated differently in the
Yeah, I
law.
mean, usually when we talk about open source, it's when somebody has actually made that decision to make their source code public, and usually that's accompanied with a license that indicates how the code can actually be used. If you need a attribute, if you need to do anything, the type of license the case that can be used with. In the case of a source leak, it's still copyrighted. It's still protected, and you can't just copy it into your own code. Not just that, but even looking at the code and then like building something off of memory can still kind of bring it into a questionable legal state because it is protected intellectual property. Now, to be fair, it's more difficult to prove that, but with something like, especially like React OS, there's a lot less wiggle room for them, especially if it's known it's public and it can be shown that somebody did access it.
If it can be proved, you're screwed.
And
Yeah.
I mean, Microsoft has a pretty big legal department. It might be
Yeah, they're a
hard.
pretty big company.
They might not go after you on the small stuff, like if you've just got some random little thing you've put out there. But I mean, it's not something you're ever going to want to use in any sort of legal project. The other place that I think there could be some use, well, actually, I don't think there's going to be much use for it, but I've seen some comments kind of questioning what the uses. But when it comes to more vuln research stuff, and I mean, in that case, just have to say, like, this is quite old code. Windows XP is not like a dominant player in the market. There are obviously still the use cases like, ATMs and things running kind of embedded Windows XP. But those also generally aren't terribly well exposed to actually be hit. Like, you're not finding point of sale systems just on the internet. Well, you probably are, but you shouldn't be.
Yeah, I mean that's where I've kind of seen the discussion going to is like, is there security implications? And this kind of reminds me of when we talked about the Valve Source Engine leaks a little while ago. I don't know if you remember that. I think it was before the break. Just before the break, we talked about the Valve Source Engine leaks, and what we said there was just because the source is public doesn't mean that bugs will magically fall out of the sky, which is true here also. But the other thing is, like you're saying, this is old code. Windows XP has been out of support for years. I think support ended in like 2014. So if you're using XP, you probably have bigger issues anyway. Like people probably don't need to use 0 days to hit your system if you're running XP. Put it that way.
Yeah, I mean, I was more thinking about the case of like how much of the Windows XP code might still be in Windows 10. Because there probably are some deep, dark areas of the Windows kernel that have survived that long.
Like
Probably not
Win32k,
much.
probably.
I mean, there's things that are like, even if they still exist, they might not be reachable through the same code paths, things like that. There probably is still some overlap code. Like you're saying, though, you still have to find those vulnerabilities. And odds are, if there is the code that's lasted that long, I'd say there's at least a reasonable chance that it's lasted so long because it is kind of hard to understand code. People have just been like, I don't want to touch that any longer, and ignored it. And that's actually could be a ripe location for bugs too. But I think just with age, access becomes different. Things change. I mean, where we are dealing with a lot of this. When was Windows XP released? Actually,
I want to say 2001 or
yeah,
something
like we're talking about.
Yeah,
Pretty
2001
old operating
October.
system. Yeah.
Yeah, so this code was written in like the late 90s. So yeah, it's a little bit old. So I can't wait to see all the articles where people are searching for backdoor and stuff like that and write articles about it. I've already seen people doing that in Discord. Searching NSA and backdoor and all these things and taking screenshots of the code. As if backdoors have glowing neon signs in the source code, like actual, backdoors, but you know, can't wait to see all those articles coming out about it. There probably already are some out there.
Never know what they've decided to put in the comments. There have been some interesting comments pointed out. Somebody did point out actually of some certificates being present, or root signing keys actually. I think it was for NetMeeting, the user certificate root signing key was present in the dump.
That's interesting.
I think it was already expired, and some of the other Twitter comments were saying the same thing, that private keys found there were already expired, which is more or less, I think, what you'd expect. I mean, being an old dump, I mean, this isn't even like SP2 or anything. This is just the original Windows XP. So being pretty old, most of the keys should be expired by now if they're present.
So there were some hidden gems in the source leak as well. There was one that I found really funny that I thought I would share that somebody posted on Twitter. Somebody at Microsoft really had a fun time with macros. They decided to basically, I guess, do their own kind of like programming language in a way in C just by using preprocessor definitions. And it seems they really liked cows. So, that was kind of a funny one that I saw, But
yeah, so for anybody that's just listening, basically using these macros, they've written out, the cow goes moo with a moo, or n moo 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 color, and a lovely bit of code there that nobody's going to understand without removing those macros.
Yeah, and it does use like it does seem to use some Windows API functions like follow, although that might be libc. I don't know. I don't think so, but anyway, that's besides the point. Anyway, yeah, there was some fun stuff in the XP source leak. One thing that I was kind of thinking of was I was a bit surprised that Microsoft didn't just at this point just open source it themselves. I don't think they'd really lose much by doing that. I mean, the source code's already public. It's not hard to find for anybody that's looking for it. So I almost feel like Microsoft should just, put it out open source and make it like an official repository by this point. What are your thoughts on that, though?
I'm I'm not sure I'd agree. I mean, they could if they
Okay.
want to. I don't think there's any reason why they should, though. Like, I mean, I guess
Well,
like having code made public certainly can add a little bit just to the public knowledge, public domain. Like, sure, there's the benefits there. As a company, though, I don't think they gain anything by doing so.
yeah. And I mean, that is a good point from Chad as well, from Supposite Wave. You know, if they made it open source and they put a license to it, it does mean that that code could be reused in other places, which I could see that being damaging against their, product, like even Windows 10 and stuff like that. When you're talking about React OS, which I'd classify as a competitor. It is trying to accomplish what Windows does without actually using Windows. So kind of the direct definition of a competitor. So yeah, that's a fair point. What I was kind of thinking of with it is that it adds to the knowledge base, like you were saying, and the big leak with or the big worry with like leaks and stuff like that is they're coming from untrusted sources. You don't know what could be in those leak files. There could be malicious stuff hidden in there. I mean, I don't think there is in this case because I think it would have been discovered by now.
Well,
But
actually, it is worth pointing out that so this was dumped, I believe, right onto 4chan. I'm not sure where the original upload was, but a lot of people are getting this dump out of a torrent that was actually released by a Redditor, I think like Bill Gates 2 or Bill Gates 3, name like that, number after Bill Gates. And in that torrent, there are a bunch of Bill Gates conspiracy files about, Bill Gates' plan to vaccinate the world, which I guess
oh
doesn't
boy.
sound that bad, but there are a few, like, the anti-vax conspiracies, things like that, his plan to take over the world, that apparently were added by a user. I mean, it makes sense given that his username was Bill Gates 2 or 3 or whatever. It makes sense that he was probably the one that added it, and those weren't in the original source. Also, I think some PDFs are sprinkled in there. So, I mean, somebody added some content to this. Like, I doubt those were actually in the original dump. Or even if they were in the original dump that was made public, probably not in the actual Windows XP source repository.
I don't think Mr. Gates would have been too happy about that being in the source code if that got back to him. Yeah. But yeah. With that said, I think we could probably move on there. It would be cool if it went actually public through open source, but yeah, probably not going to happen. So, are you a fan of Critical Bug, Z? Because this person isn't apparently. So this post on the Daily Swig was apparently the first bug bounty millionaire, which I'll get to in a little bit because I do question that claim. But it's about this kid, Santiago Lopez, and his views on like bug bounty hunting. And the headline quote in there is, "I'm not a fan of critical bugs." So a lot of the bugs that are talked about in here, some of the stuff that he hunted was like server-side request forgeries, indirect object references, and like cross-site scripting.
Yeah,
So it's
well,
not like binary stuff. It's mostly web issues.
which is what a lot of the bug hunting is when it comes to like a HackerOne bounty. That said, I want to jump back on your statement, questions about him not being, or about being the first HackerOne millionaire. I thought we might have even talked about this on one of our early episodes when, or no, I guess it would have been just before our first episode actually that this happened. But what's your question or concern there?
Well, if it was the first HackerOne millionaire, I might be able to see it. But I don't think they say that. They say the first bug bounty millionaire, which I don't believe that's the case.
So
Because
it's HackerOne in particular.
they do focus in on HackerOne in the article, but they don't make it
That's what
clear
he
that
is. That like you can go look him up. Like HackerOne did make that statement. They link here. I guess they don't link to the HackerOne statement, but teen becomes world's first $1 million bug bounty hacker on HackerOne is what they link to.
okay, so maybe
for
it's just
saying
bad wording by the article then.
Yeah,
So,
no,
fair
he's
enough.
known for the HackerOne aspect of it. If you want to open up bug bounties to being like exploit sales, then probably not.
Well,
But if we
definitely
want
not.
to talk about just like these public bug bounties, I think there's still a fair chance that being the first one on HackerOne would also be among the first, just because bug bounties haven't been that popular for that long with good payouts, or with a lot of companies even offering payouts. So I'd still kind of buy that, but yeah, this is specifically, he's known for the HackerOne aspect.
Yeah, that's where my gripes came from, because where I was thinking of when I heard that was like, okay, what about ZDI? Because if you consider that bug bountying, then there's people on ZDI that have absolutely made $1 million by now. I mean, if you look at some of the payouts and stuff for like Pwn to Own and whatnot, it's kind of impossible that he would be the first to reach $1 million. But yeah, if you throw in that it's specific to HackerOne, then I'm a little bit more forgiving in that sense.
Yeah, I mean, when people talk about the bug bounties, I tend to automatically think about companies offering like their own vulnerability disclosure program, and that's the bounties that they're going for. Some like ZDI's kind of third party.
So you wouldn't consider ZDI a bug bounty?
I think you definitely can. It's just you have to be clear about what type of bounties you're talking about. And I think the default when people talk about bug bounties is referring to the Bugcrowd, the HackerOnes, just the Google program, things like that, like the first party disclosures. It's fair to consider ZDI a bug bounty. I just don't think that's necessarily what people are thinking of most of the time when they talk about I want to, do bounty hunting. They're probably not thinking about ZDI.
Okay. So, I mean, I will say there is kind of a level of arrogance in some of the statements in here. The one quote that I kind of picked out was, "I spend 6 to 7 hours a day hacking, which is more than most ethical hackers." I think that's a very bold statement to make and not something you could really know. Not to mention hacking is very vague. Is hacking vuln researching? Is it finding and researching targets? Is it just using a computer? Some of the statements in here are a little bit wonky. That being said, I do think there are some insightful, quotes in here as well. The biggest bounty earned being 9K is one thing that's mentioned in here, which seems kind of in line with HackerOne. I think the highest pay I've seen in HackerOne, I was about to say Valve, but actually Sony, because Sony they've paid like $40,000 for bugs, and their bug bounty is like really new. It just opened up a few months ago. But I think, he talks about wanting to find the highest value bugs you can find in the least amount of time. And that's where that quote, "I'm not a fan of critical bugs," comes from, which I think might be a fair point that a lot of people ignore. That, it might be worth the trade-off to find more trivial bugs than less really cool bugs if it means you ultimately get paid more in the long run.
Well, so this is actually kind of where I see a downside of doing the bounty hunting. A lot of the work that you need to do kind of changes from doing like an analysis of a product, finding these deep security issues, the cool issues, or maybe not so cool, but finding those deeper, more subtle issues. And instead just scanning a bunch of targets kind of for the same basic vulnerability classes.
Just going for low-hanging fruit.
Well, I mean, it doesn't necessarily have to be low-hanging fruit in the traditional sense. It could be stuff like, with all the desync stuff recently. Like, about that attack. I mean, I guess you could call like some desync scanning low-hanging fruit, but it can kind of imagine just being like, you're only looking for very specific issues across a wide range of things, find everybody that's just vulnerable to the same thing. So in this case, like, he did the scanning for like the IDOR, the insecure direct object reference, as being his specialty, as finding those. And I'll be honest, it reminds me a little bit basically of why I left one of my last jobs, which was, I was doing the AppSec, get tossed on a project, do the assessment, having the time to find some of those deeper bugs, but I kept getting put on these projects that were generally all the same and all these really stupid issues. It became extremely boring to keep writing up the same problems and the same reports all the time, and my manager wouldn't put me on anything else, so I ended up just leaving. It's like, I can be jealous of, him having $1 million out of doing that, but I don't know if I could even do it. And I think that's something like with the law of bug bounty hunters. you've got to take that into consideration, that you're not necessarily going to spend an insane amount of time really digging into things. If you want to live off of it, you need to have the income coming in, and that comes from a lot of these lower paying bounties.
Yeah, it started to kind of become tedious. And that's one thing that like kind of pushed me away from web in general, was just like I feel like a lot of these types of issues you can just find them with an automated, pen testing tool or something. Like it doesn't really require a lot of manual digging. I mean, you can manually dig into it, but you don't really have to,
You still have to do the recon for it. Like, even if you're like, especially like IDOR being the good example there, odds are all of the obvious cases that your scanner is going to come across, most likely those are already going to be protected. It's finding those random oddball endpoints that actually are vulnerable that somebody just kind of overlooked adding the security onto. So I don't entirely agree there.
Okay.
Like, there's a lot of web stuff that is not just done through automated means. You can do some automated testing, but there's still a lot of stuff to be done by hand. Automated tests tend to give a lot of false positives, miss a ton of issues. They just can't do very well, in my experience.
So I wanted to have a bit of a discussion on making money in the industry with regards to bug bounties, because while this guy, made a lot of money, I mean, we're talking about $1 million, that doesn't mean that everyone will, or that it'll be worth it for everyone. I mean, you were kind of just saying there that, even though he made a lot of money, you don't think you could do that for, every day, day in, day out. You wouldn't enjoy it enough. And that's the thing, like, I guess that does come down to the question where you kind of have to really put yourself through some torture to be able to make that kind of money through HackerOne, I think. So I do just kind of want to maybe make a bit of a statement there that it seems when these kinds of articles are put out there, people are like, oh, wow, I should go and do bug bounty hunting. I'm going to make $1 million. And they don't consider all the nuances to what's actually involved and how much time you're putting in and getting like relatively little. Like, this is $1 million over a lot of submissions. It's not like it's one submission that netted them $1 million or anything. A lot of these issues pay out like $1,000, or you're lucky if even that, probably, for a lot
Yeah,
of
and in
them.
fairness, I mean, it's about $1 million over 3 years. Started when he was 16, made the million by the time he was 19, which is still pretty good salary. That's, in the mid 300,000s per year. Professionally speaking, odds are, job doing this, you're probably not quite going to be making that much unless you're either senior, managing some projects in a higher cost of living location. He was I believe this guy's from a fairly low cost of living location.
I think he's Brazilian. I think that's, if I remember correctly.
Yeah, so I don't know cost of living in Brazil, but I have to imagine that it's not quite as high as, say, New York, where you might be seeing that type of salary. So like, he was making more than the conventional wisdom would say, do bounties on the side, and once you've got a few, you should be able to actually get a job.
This wasn't US dollars, or was it actually outright stated? I imagine it probably is.
It is US dollars, HackerOne.
Okay, fair enough. Yeah, I mean, basically what I come down on there is just know that is a lot of time and effort put into, getting that kind of money. Like, you're probably not going to be putting yourself through as much like gruesome work, working like a salaried job either, which is where, bug bounties, they're more volatile. They're not a guaranteed source of income. You have to put the work in to be able to get any money out. So, there's a little bit more risk there, and that's why we've kind of said in the past, like, I can't remember the story we talked about. We were basically saying it's usually not a good idea to base your living entirely off of bug bounties, just because of the super volatile nature.
I mean, it's worth noting that your salaried job, you're still putting a lot of time there. 8 hours a week you're getting your 40-hour week in there. Sorry, not 8 hours a week, 8 hours a day, 5 days a week. So your 40-hour week, that's a lot of hours, and you're not going to be making quite as much as he was.
I mean,
That
that's the
said,
hours you're scheduled. How many people are actually working,
well, even if we take
full
like
speed ahead,
your
8 hours a day?
even if we take like his example of like 6 7 hours, so you're say only doing 6 hours, so you take like your hour long lunch break and you slack off for an hour or whatever. It's still comparable hours, although you can argue whether or not you're actually productive over that, but you'd also have to argue that he may not be as productive over that time also. Like, it would be the same issues there. So hour wise, like, it can be somewhat comparable, but with a salary job, there's a lot less stress on you. It's you do your job. um you're not dependent on actually having the findings, so you can spend time actually looking into things without worrying that you're spending time uh improperly, where it's like there's some that look suspicious, I can go dig into it without worrying about how much I'm losing out by not finding other issues. And especially the other thing with bounties is finding issues first and before somebody else has reported them.
Yeah, you have to worry about collision. So the last interesting quote in here that I wanted to touch on was he was asked if he ever had any issues when it came to like responsible disclosure, and he said the truth is I've never had a problem with responsible disclosure. So since the bug bounties being talked about were all on HackerOne, I could see how this might be true. It's definitely not true across bug bounties in general. We've talked about many reports and stuff on the podcast where there's been disputes between the company and the researcher, and even going as far as like potential lawsuits and stuff like that. But I think this is kind of a highlight of what platforms like HackerOne bring to the table. Because generally, if a company has a HackerOne page set up, it shows they care, at least to some degree, and they do care about fixing those issues. And it kind of is like a really good platform for establishing that medium of communication. Um, and that quote, I could see it being accurate, and I think that's kind of a something that shows what HackerOne brings to bug bounties in general.
Yeah, I think a lot of the issues that researchers tend to have tend to be derived from the fact that the researchers don't follow the scope, don't follow the rules of engagement that the company has put forward. So he's mentioning like he's followed that and hasn't had any issues. That's generally true.
Yeah, and that's the really nice thing with HackerOne is all the companies on their pages, they have, what's in scope, what's out of scope, what you're allowed to do, what you're not allowed to do. Whereas, if they're running their own bounty page or if they have no bounty, that becomes a lot more muddied. It's hard to know if you're on the right side of, you know, um, I guess what's right or what's legal. So we've been talking a lot about HackerOne, so we'll jump into some reports on HackerOne. So our first one is API keys being leaked through the Solana BBP GitHub repo. So this one is kind of an I'll say interesting report. I know Z, you kind of wanted to talk about this more at a meta level than the actual issue, if you can even call it that.
Yeah, I mean, kind of talk about the actual issue too, but when I first saw this, I didn't entirely read it, and I thought that the report here was, basically as the title says, secret API key leaked. I mean, they all say public and secret API, but key part being their secret API key leaked. And, then they have their proof of concept. They have a link off to this JSON file that includes, obviously, JSON dictionary, has an environment dictionary containing a bunch of tokens, including some API keys. And there's a comment in there, like entry is _comment. These credentials are encrypted and pose no risk. So I thought it was about that. Somebody's reporting the fact that they have encrypted credentials. And so I was going to, and I mean, I will go into it here, was going to talk about kind of the impact of the encrypted tokens being present in the source code. Not an ideal situation to have. You generally want to keep the token just completely out of source. That said, encrypted tokens don't present an imminent risk. You do still need to be able to decrypt them. Presumably, the decryption key is stored elsewhere, is not accessible through just the source itself. So I mean, this is something where, like, on a report, I might include like a observation. I might say like, hey, this isn't a best practice. Here's kind of what you should look at doing, implementing a secret servers or using a service for that, going kind of that route rather than doing it encrypted in there. But it doesn't pose like an imminent threat to anybody. That said, what this report actually is about is, if you read the impact at the bottom, public key exposed in GitHub repo. Public key exposed. Isn't that the point of a public key?
Yeah, I think they're kind of missing the public part of that sentence. So, yeah, very interesting report. That was kind of LOL worthy. But one thing I know you kind of wanted to talk about was, do bad reports like this hurt the industry, and how much do they hurt the industry? Is kind of what you were.
Yeah. So at a more meta level, I did kind of want to make the comment, like, these sorts of reports and creating this sort of excess work for a company, it's kind of why some companies will avoid even having bug bounties in the first place, or even having a vulnerability disclosure program, because they're going to get these people just submitting worthless reports to them. I mean, they have a comment in there saying these credentials are encrypted, so even if they're reporting that encrypted aspect,
they already know about it.
They know about it. They've made that decision to ignore that. They've made that risk assessment themselves, and that is a decision that they can make. Like I said, if I were coming in on like an engagement doing the assessment, even if I saw, like, I would still call it out as an observation. This isn't best practice. I'd even include a note. You're already aware of this. We're calling it out, though, because that's our job, is to call these things out. I don't know. With the bounties, I feel like you want to have a higher kind of signal to noise ratio. You want to be providing benefit to the company, and these sorts of reports, I think, can kind of damage that relationship between researchers and the companies that have these programs. If they get a bunch of reports like this, ultimately, I think it's kind of hurting the reputation of everyone.
You're wasting the triager's time. And like you were kind of saying earlier, I think gives companies something to point to justify why they shouldn't or don't need to launch a bug bounty program. It just looks bad on researchers. Yeah.
Although I guess, as we were kind of just talking about, sometimes you're wanting to report those lesser issues just to get a payout. So I mean, you see something like this, it's an easy potential payout. So I guess, like, there's a bit of a incentive, I guess, to even just report anything.
Yeah, I mean, especially if you get lazy triagers that don't really check into things too much, I could see how maybe, like, you probably wouldn't get much, but, there is definitely an incentive to kind of fudge reports to seem more impactful than they actually are, to try to get payouts, which is kind of another, negative blight on bug bounty stuff.
So we were talking about, just a little bit ago, we were talking about the highest payouts. How much was the Sony payout?
So the Sony, I was thinking of the PS4 and PS5 stuff. A PS4 critical, I think, is $50,000. Though I think that talks about like compromising the system at like a crypto level, which is obviously extremely difficult. But when you're talking about like, there was like some Blu-ray stuff, I want to say, that was disclosed on there that they paid out like $40,000 for. So there were some pretty high payouts on the like thanks page or whatever for the Sony PlayStation, I should say, bounty page.
So the reason I brought that up was because I noticed that their payouts here under their policy for the Solana BBP is criticals at 20,000. I didn't remember what the Sony one was, so I mean 20,000 still kind of high. So I decided to take a really quick look at if they've had any critical reports. And they actually have this sensitive data leaks, username, passwords, keys. And so you click on that, and one of the files is the same one as the report we were just talking about, the secrets.ejson. And the other one is Docusaurus config.
What's the report ID on that?
Looks like 961170.
Oh, okay. The reason I asked was because the report we were covering actually was closed as duplicate, and it has duplicate of another issue number, but this one was 964302.
Yeah, I tried to go to that duplicate one, and obviously you can't go to it. It's a private report.
Yeah, so
Um,
I do kind of wonder if, somebody else was just trying to do the exact same thing and it was closed as invalid or something, and for whatever reason they didn't want to close this one as invalid and just close it as duplicate, but
yeah, and I'm going to say that is something I forgot to mention when it comes to severity. Rating that as critical, or in this case as high. If because they're encrypted, it doesn't pose an imminent threat. You have to take into consideration what you're able to do with this vulnerability if you're
the
going to give it a
circumstances of
severity.
it, yeah.
Yeah, just because, like, in theory, these tokens could actually be quite useful. The reality, though, with them being encrypted is you can't do anything directly with them. You need a further issue. You need to be able to leak that key. So you wouldn't rate that as a high on its own. This is a
leak the key
defense
or
in
break the
depth.
crypto.
Yeah, it's a defense in depth issue. So the severities automatically should be lower. I mean, the other person rated this as critical. Now, I'm not sure what that other file was that the other report had. But it's just something to point out. Like, don't inflate your values, because again, that just starts looking bad when you do that.
Yeah. So getting into some actual issues, we have Tiny RSS, or TTRSS for short, and this blog post by Digix, I want to say. I'm just going to say Digix. I think that's how you say it. But they basically dive into Tiny RSS and they give a bit of insight here into vulnerability hunting in open source software. So they talk about multiple issues and even just some interesting quirks they found while they were, researching into it. Mostly in the base plugins, which is notable because these issues can be exploited if the plugins are installed, which they are by default. They don't even have to be enabled, according to the author.
So a lot of these issues were all actually in one specific plugin, the image proxy, or AF proxy HTTP, I think was the file name. That's where, so there are a few issues there. There's cross-site request forgery and denial of service. That's kind of in the core code, but then there's reflected cross-site scripting. That's in that image proxy. Local file include in the image proxy. Another reflected cross-site scripting, some kind of in the caching system, which you end up getting your file cached through the image proxy, and then you access it through the public PHP code. Server-side request forgery and RC comes through the image proxy. And access to local file inclusion is just chaining the above issues largely through the image proxy. So a lot of this comes down to their one plugin, the image proxy, which is enabled by default, but it's not like there's a bunch of plugins here to get fixed.
So while they do have this blog post, they also do have a separate PDF report, which is more akin to something you would see from like a pen testing firm or something.
Yeah, it's more it's a more professional report.
Yeah, so if you want to find like more information than is in the blog post on all the vulnerabilities individually, you can check out that PDF report, which I think is nice that they provided that. I don't think we always get that. Overall, there were 3 CVEs that were assigned, but not everything got a CVE. So I think the CSRF or the SSRF, the local file inclusion, and the RCE got CVEs, but I can't remember exactly which issues kind of weren't assigned CVEs. But anyway, getting into the timeline, the developers were contacted.
Before you go into the timeline, actually,
okay.
I do want to dive in, not too deeply, but I do want to talk a little bit about the issues.
Okay,
Notably,
yeah,
I've mentioned how this image proxy was kind of the root of several issues. It had a pretty simple issue. It was just the fact, like, you could write a file : / as like the URL you wanted it to request, and that would end up reading local files. So pretty straightforward issue. It's just one of those things to point out that people kind of forget about kind of how PHP has. I mean, there's that file. PHP kind of has its own little PHP protocol specifier you could use that you could do, like you can pull files out base64 encoded. There's a bunch of really weird things, so you usually want to whitelist that protocol specifier.
Yeah, and that specifically was libcurl. I'll just throw in there.
So no, libcurl was when you came to the actual like XS to LFI stuff. So you would use, well, part of libcurl came in both with a server-side request forgery. It would get called over using curl, but the file stuff I think hits curl, but I think part of it also. Sorry, I am mistaking two different vulnerabilities here. You're correct. That was curl hitting the file. My bad.
Yeah, because they used a custom file, or they used a custom function to fetch the file contents. They didn't use the file get contents
I was
PHP
thinking,
API.
I was thinking they were using that API, but no. My apologies there.
Yeah, no worries.
So yeah, just remembering, I guess, that file, you can't really use the PHP ones against curl. The RCE that they got, I thought was a little bit interesting because it would abuse the Gopher protocol. Opening up using curl, trying to open up Gopher : / to look, in this case, in the default setup on their Docker setup, localhost 9000 would have PHP. I think that's the fast CGI.
FPM, yeah.
Yeah, fast CGI. I forget what the PM means, but it's the handler that you get in for that. So you use Gopher to kind of just send a raw packet. Well, not a raw packet. You control the content though, so you can kind of pretend to be other protocols to send a fast CGI packet to PHP FPM running on localhost 9000, and that would get you the code execution. So I thought that was a kind of interesting chain that they went through for that.
So was there other issues you wanted to jump into?
I was just trying to find it on the blog post, but it might have been in the, or I think they went into more detail in the actual report.
Oh, okay, fair enough. So I did kind of want to jump back to the timeline because I think it does kind of reflect well on the project maintainers.
Yeah, for sure.
So the developers were contacted. They say 11th to the 14th of September, and then they were fixed between the 14th and 17th. So they were fixed within like a week. And the findings in the blog post were published on the 21st. So this was all resolved in like 2 weeks. So that is one thing with open source you don't see incredibly often. Sometimes with open source, people report issues, and then the open source developers are like, well, I just don't see this as an issue, or nobody's ever going to use this, so I don't really care. I'm not going to bother, pulling in your PR, or I'm just not going to address your issues. But that wasn't the case here. In this case, they took them seriously as issues. There were even CVEs assigned to them, which, is a little bit more rare, I think, when you're talking about open source projects, unless it's like a major open source project.
I believe Digex, or however you say their name, were the ones that made the CVE request, not the open source developer. While you need the coordination between the two to actually validate it, I believe the request was initiated by Digex rather than the developer going through. That said, I will also mention that it sounds like they sent 2 emails at the start, one on the 11th and then another on the 14th. So you have in brackets, your first email got lost. So it sounds like the developer may have fixed this basically within 3 days, just got the notice on the 14th and immediately fixed it in 3 days.
Yeah, which is awesome. And what I was saying with the CVEs there is, the developers didn't refute it or anything. That reflects good on them. The PDF report does have some cool stuff in there. I think it's 37 pages long. They don't provide any proof of concepts. They say that's, in order to not enable script kiddies or anything like that. I like the blog posts. They jump right into the issues and do a good job of breaking them down. I like that they include the PDF report separately for people who want to jump into the details more. So some of the things that the PDF has in it is like the vuln details, recommendations, references, and the fixed commit links from when they were eventually fixed. So yeah, like I said, reflects well on TTRSS. They were even, I don't know if you saw this, by the way, DigiX was even praised in an announcement. So TTRSS, they have a forum, and they put out an announcement on the forum about these issues and them being fixed. And in that thread, the developer said, "I'm going to add that dealing with them was very enjoyable, and information I received related to vulnerability findings and methodology was clear and concise. 5 out of 5 would fix bugs reported by them again." So, that's kind of a wholesome quote from the blog post.
Yeah, you don't want to fall into the case that they wouldn't fix bugs you report.
Yeah. So, jumping back to HackerOne, you know what? We've got another HackerOne report. So this one is a reflected XSS in the Wistia hosting site, which is used for like marketing videos and stuff like that. And basically, one of the scripts they found is vulnerable to prototype pollution. So this is kind of an issue I haven't really seen before. I don't know if you really have seen this much before, Z, in the past.
Yeah, it's been kind of getting a little bit more common here. I mean, I want to say it was... So prototype pollution as a term exists before this, but I want to say as like a vulnerability, it's kind of being called out from like 2018 or so. So it's still a relatively new thing that people are looking for. I mean, the vulnerabilities, I know it's gone by some other terms because I've seen the same concept applied in different ways. But the idea here is, or the idea with this one actually, so it's in the Wistia code, but it's kind of in how it initializes embeds. So that's where it comes into HackerOne and executes in HackerOne. They use the example there with prototype pollution. Basically, when you apply something to an object.prototype in JavaScript, that gets applied to like every object that has, or of that type will have that property of whatever you assign it. And in JavaScript, people will kind of copy objects by just iterating all of the properties and applying them to another object. They'll kind of merge objects that way. So if you can control the property that's getting assigned to and set that to the __proto __, you can kind of set properties on these general objects, which can let you do things like, say, in this case, set the inner HTML of like all the objects of that type through the prototype pollution. I probably didn't explain that too well. Like I said, it is a reasonably newish attack. It's definitely been getting more popular. Like I see reports on HackerOne coming up increasingly frequently involving this. So I think it's one of those issues that's something that you probably want to pay attention to if you are doing bug bounties. This is something that's picking up right now, worth looking into. But anyway, as I said, their embedded initialization takes a hash map of the properties and plugs them all into a new dictionary. So it gets some of these out of the URL. So by appending that, or by setting a __proto thing in there, you can go ahead and set the inner HTML, which is pretty much exactly what they do. They set the prototype of the inner HTML on here in their steps to reproduce. They set an iframe. So there is a content security policy in place, which usually will limit some of what you can do with cross-site scripting. But the CSV policy allows for a content out of star.cloudflare.com. So you can get a lot of, you can include a lot of code. So they're able to include, I believe they use AngularJS to basically break out using an iframe with a source doc, loading Angular in there, adding their blob, and they had generic cross-site scripting through that. So straightforward on the CSP bypass.
Yeah, because
oh, go ahead.
Yeah, because I was gonna say, like, Cloudflare has a lot of people use their content delivery network, right? So anything on cdn.cloudflare.com can be used in this kind of attack because of that whitelist.
Yeah, because of that. I mean, ideally your content security policy should be more specific, but it's not in this case, and they were able to get around with that, or able to get around that. So yeah, the vulnerability is actually in Wista's code. It just impacts HackerOne because it runs on HackerOne's within that context. But yeah, definitely, like, prototype pollution is definitely something I think to pay attention to right now, or if you're doing those bug bounties, to kind of be looking for, because I have been seeing a lot more reports of that lately.
Yeah, I think this was a cool issue. It was kind of new to me. But yeah, like you said, HackerOne staff, they coordinated with Wistia to get them to fix it. The researcher was awarded a $500 bounty and a $50 bonus for testing, which we kind of mentioned, I think, on the last episode, which, I kind of commend HackerOne for. That's pretty cool that they do that. But yeah, I think this is a good, PSA kind of reward, I guess, for bug bounty hunters. So, keeping it going with the HackerOne train, our next one is in Steam. This one is more of an exposed debug feature than anything, as far as I could tell. Basically, they have this dev kit endpoint, which is presumably for listing shortcuts based on the URL. And you can specify a response parameter, which specifies where that response is written to. And you can basically link this to someone and make it arbitrarily corrupt a file by just specifying a different file to where the response is written to.
Yeah, it's kind of like a potential denial of service ish if you can target the right file. Like you said, it's just a sort of dev endpoint that's exposed. You can overwrite any file. You can't really control the contents of the file. You can just overwrite any file. So they give the example of overwriting like the home directory.ssh id_rsa file. Could do some damage there, but you kind of need to know the username in order to do that one.
Need a bit of the layout of the file system.
Yeah, well, I guess I don't know for sure here if you can do the relative addressing or, just use the tilde.
Sorry, we're just responding to something.
Yeah, sorry. Kind of went silent there. So anyway, with this report, I mean, like I said, it's a development endpoint. I think it's kind of interesting though, I don't know, these kind of handlers. So in this case, it's like the protocol specifier of Steam : // I don't know, we've called out a few issues that kind of deal with things being exposed there that shouldn't be. So I kind of find that it's just another case of those being abused, of those having too many features or doing things they probably shouldn't do.
Yeah, it seems like it could be a farm of future potential issues. We've
covered quite a few issues like that over the show.
Yeah.
Yeah, fairly straightforward. The other thing that I thought was just a little bit funny with this one was that they called the weakness here a write what where condition.
I have a problem with that. Yeah.
I mean, so write what where is usually more of a binary exploit where you're able to write some piece of memory to some location. You're writing what you want, where you want type deal. Or a partial write what where. That exists too. But the idea being, it's usually a memory corruption thing. I get where this guy's coming from on trying to apply it here. You are like writing something to a location. But as like even the CWE, if you check it out, is in reference to memory corruption. Like this wouldn't quite fit there, but I just thought it was kind of funny that he used it there.
My kind of problem with it is write what where implies that you can control the contents that are written. It's kind of in the name, write what, assuming you control the what where, which isn't the case here. This is basically just like a file corruption primitive. You don't control what's actually getting written there. So I do think write what where is a little bit inaccurate. It's probably not the best term to use there. So
well, I mean, as a
that's
CWE,
kind of my only problem with the report.
As like a CWE, it's pretty much wrong because it's not a memory corruption issue at all.
Yeah.
And I mean, I could double check on that. I think I checked before the show though, that the CWE was in reference under memory corruption. Oh no, I kind of get where they're coming from with adding that. I get where you're coming from saying that you need to have the what part of it, but I mean, partial write what where exists too.
Yeah. So this researcher got a $750 bounty. This issue was reported over a year ago, but just went public on the 22nd, which is it's pretty much par for the course when you're talking about Valve. The original post is also hidden. Basically, all you see here is the Valve summarized report. So all the comments and back and forth between the reporter and the Valve employees are all hidden, which I actually don't remember picking up on before, because we've covered Valve HackerOne bounties on the podcast before, and I don't remember catching that. But yeah, it's not surprising, because Valve is a lot more sensitive when it comes to reports. I mean, like I said, they took over a year for this one, and our next one they actually took even longer than that. So this is a pretty old game. We're talking about Half-Life 1. I don't remember the the release date for that. The funny thing, in my notes here, I actually have a Valve report for Half-Life 3. I don't know how that meme ended up entering in my notes. I didn't do that intentionally. But yeah, basically a code execution in a malformed map name. And it's a fairly straightforward map file name Stack Overflow. So, you have to be able to list the installed maps to be able to, hit this bug. So one thing they mention is like opening the console and issuing a command to list the installed maps. There's not too many details on how they actually exploited this issue. There's basically a stack trace and not much else there. They did get a $1,500 bounty though, which did surprise me a little bit. Valve has always been pretty good with payouts, but this does seem kind of like this is a very old game, and it does have a bit of a limited impact from what I can tell. But
I mean, all
good
games though are going to be somewhat like anything inside of a game is kind of a limited impact. Granted, some games are more popular than others.
Well, the reason I say limited impact is like some of the CS:GO exploits you see, it's when you join a server that's running a malicious map file, which is, not super hard for people to get infected by doing. Whereas this one, you have to actually install the map file yourself and list it out, which
fair.
I don't know how, how easy
point.
that is to do unless you're doing it intentionally. This does seem like kind of a fun exploit though. Because the details are kept kind of censored and there's the stack trace and not much else, this could be a fun issue to dig into. I mean, I feel like if somebody wants to get into binary exploitation, or they just want like a fun, CTF kind of like challenge, this could be something that could be fun for you to do. Try to take this stack trace and the information about this bug and turn it into an exploit, and write like a proof of concept or something. I think that could be a fun exercise for somebody to do.
Going from what you see here, it's an sprintf where the crash happens. So I would assume stack variable is holding either reading the map name, sprintfing it into the variable, and that's where the overflow happens. So I mean, I guess the question is there going to be ASLR in place? And being a somewhat older game, and running on Linux is the other thing. I'm making the assumption here that ASLR was not running, or was not like having an impact there. I don't know about NX, and I don't really know if games generally have NX on or not. That's not really something I've ever really looked at, but I mean, it does seem like it's a straightforward stack smash.
The other thing when you're talking about stack smashing in terms of mitigations is also stack cookies. But
which you're not going to really have in a lot of games because that's overhead.
Well, not only that, Half-Life 1 was also released in 1998. So I very much doubt that there's any of these mitigations are even going to be present. So it's probably a fairly straightforward exploit to go through with.
Yeah, I didn't realize this game was that old. I've never played any of the Half-Lives.
Yeah, I mean, I knew it was old, but I thought it was early thousands. I didn't think it was the 90s, so... Yeah, I feel like a true Zoomer, because the game is literally older than me. So, so moving away from HackerOne, we have uTorrent. So this is a vulnerability in the uTorrent client, which is probably still reasonably popular in the torrenting community, though I can't say I know why. It's been bloated adware garbage for a couple years now.
I know a lot of people use old versions of it, not the latest stuff. That might not necessarily be true. But I've known a lot of people who've stuck on the older versions.
Yeah, basically, moral of the story though, don't go with the newer versions. It's just horrible. There's ads everywhere, and it just sucks. But yeah, anyway, in the uTorrent client, there is an issue in the handshake portion of the BitTorrent protocol for peer-to-peer. So they kind of break down the handshake packet format. There is a bit more of a research aspect to this post as well, where they go into some of the background information. More specifically, they dive into the extended handshake packet format, which can be sent if both peers kind of agree and have that extension protocol bit set. So they mentioned some of the fields that this extended handshake packet has, being like the length, the message type, the extended message type, and M, which is kind of like the overall container of the data. So in this case, it's a dynamically sized dictionary of supported extensions, which they call a Ben-coded dictionary. So the way this dictionary works for storing strings is a little bit weird. I don't know if you've already scrolled down to it, Z, but basically how they specify the length of the strings is they have the length of the string prepended to the string itself. So where most like dictionaries and stuff, they'll just use like a null terminator to delimitate between strings, or they'll use like JSON or something with quotes. This just uses a length that's embedded right in the items, and that's kind of interesting. I don't really know if I've seen that there.
It's not terribly uncommon, actually. PHP uses that in their serialization format. I think Java might also. Actually, and I mean, even taking that idea, correct me if I'm wrong, I want to say natively Java strings will prepend the size to the string as or the C++ do that.
C++ string containers, I think, have an internal size.
Yeah, well, and what I'm saying is I think it's Java. This might be really old information too, where that internal size is stored immediately before the string. So like if you were accessing index 0 as the start of the string, index -1, which I mean you can't do in Java, but -1 would be the size. That said, I mean, that idea of having the string or having the size at the front makes sense. I do know PHP serialization does this. It's slightly different than this Ben coding, but this is an uncommon way of coding. I think Pickle might do it too. It's Python. No, actually, Pickle probably doesn't do that. Pickle being Python serialization. Either way, I'm just saying, it's not that uncommon to see that. What is a little bit weird, though, carrying on with what the vulnerability is that uTorrent basically tracks how deep into the nested dictionaries, because you can keep nesting these dictionaries, how deep it is by just flipping a bit in a 32-bit integer. So it goes one layer deep, it's flipping that bit. On the second layer, flips the next bit, the 2-bit, and then flips the 4-bit, 8, 16, 13, and just kind of keeps flipping the bits to mark how deep it's gone. So you can maybe guess where we're going with the vulnerability is what happens if you go beyond 32 layers deep. Well, you get a crash, which is the vulnerability here. Just a denial of service. I can't think of any way you would actually exploit, get code execution from this. Obviously, you could exploit it just by sending a torrent file with this to somebody. But as far as I know, you can't really exploit this issue to get code execution. You have any thoughts on that, Spectre?
So I'm kind of similar. I didn't really see how they could exploit this issue. They do have some information about how you could target somebody with it. You could do it remotely with a remote peer with extended messages, or with a malicious torrent file. But they don't really go into if it can actually be used to get code execution, which I think is probably something they should have been more clear on.
They do say, the source is a null pointer dereference, so generally that's not all that exploitable these days.
Yeah, I was just gonna take a look at the CVE identifier and see if there was any the CIA, if the CIA metrics have anything on that. Just taking a quick look here.
Yeah, so my guess is that just going to be a straight denial of service. That seems kind of be what they're going for. The title being vulnerability, technically it is. Denial of service is absolutely a vulnerability. So I can't fault them for that. I'd have liked them to have been a little bit more upfront. just because I saw this and I thought it was going to be something like code execution. Maybe that's just my own bias. That's fair too. That said, I did want to open up the actual file here. This is what the torrent looks like that's vulnerable. Basically, it's exactly as you'd expect. It just keeps nesting these dictionaries. Size 1 dictionaries contains a size 1 dictionary, contains size 1, just nests all of them, and ends all of them at the end there with the ease. So it's a very readable exploit file.
So the CVSS does indicate that availability is high, but impact and confidentiality are none. So
yeah, which is
just
what you would expect.
So
although, I wonder if you can come up. This would be more of a CTF challenge. Some way of taking this sort of issue and making it something that you could exploit, making it something.
I feel like it'd be really hard.
Yeah, because it is just flipping those bits kind of consistently. But I feel like you might be able to come up with something there. I don't know. It seems like a weird way of tracking this that almost feels right for like a CTF to have had it.
See, that's where I was going to kind of go. I kind of had two questions. For one, I don't really know why they have to prepend the lengths like that, just because, I don't know why they can't just use like null terminators or something. But even jumping into how they track the layers, I don't know why they do it as like a bit field. I don't know why they don't just use it as a counter, because if they use it as a counter, you would have to nest like what's the max even sign size of a 32-bit int? Like hex.
You'd have to go
7FFFFFF. Like you'd have to have so many nested dictionaries that it wouldn't even be reasonable. So I don't know, like if they just use it as a counter, this issue probably, or it would at least be mitigated, But,
yeah, and I don't know why they did that, but I agree. Like it feels like a weird way of tracking how deep it's gone. Because,
you know what?
It seems like it's extra code to do that versus just incrementing a value.
Thinking about it, I wonder if this is one of the prime examples of the evils of premature optimization, because a bit flip will be probably faster than incrementing and checking. But I mean, do you really need that level of optimization when reading a dictionary in a torrent file? I would assume probably not. So this might be another kind of testament to that point of pre-optimization, issues biting you later.
Okay, so actually, now that you're mentioning that, because this also happens during the extended handshake. So in theory, this is between peers. If you're somebody that runs a lot of torrents, let's say, a couple hundred torrents at a time, multiply that, even just a handful of peers. But if you're somebody running like that, you're probably running, you're probably seeding a lot of files. Yeah. So you've got your hundreds of torrents going there. You've probably got like some popular torrents with more than just a few peers on it. I could see them needing to optimize that a bit.
So you don't think it's a premature optimization, just an optimization?
Oh, no. I still very well might be premature. I just don't know. Like, I don't know if that's actually going to have much of an impact. I'm just stating that, like, I could see where some optimization might be necessary. I don't know. Like, I'm a big fan of actually just, if you want to optimize something, go take a look and see if that's actually the place to optimize or if something else is your issue. They might have done that with uTorrent. I don't know what their development practice was on that. It just seems like a really weird method.
Yeah. So, it's a little bit weird, and it's definitely not a conventional type of exploit. Usually when you hear of like an overflow, it's kind of straightforward. It's just like a size check or something like that. But this with the nested bit levels and nested dictionaries and bit levels and stuff like that, it's definitely the first when you go down to that kind of specifics for me that I've seen. But yeah, not too much there to talk about other than the fact that it's mostly just a DOS. It can't. I doubt it can be used for code execution, sadly. So with that, we'll jump into some of our more clickbaity stuff, which is Instagram. So Instagram, this post was actually from a 14-year-old kid who accidentally found an XSS in Instagram. So he was working on an app to make Instagram filters on mobile devices, which I'm not an Instagrammer, so I'm not totally up to speed on all the lingo that he kind of uses there. But in order to understand how to do that, he had to understand how the Spark AR filter creator app interacted with the API to generate filter preview links. And the blog post is a little bit hard to follow. At least it was for me. But I believe the issue boils down to the name of the preview for that filter. Because while it's not displayed directly on the app or anything like that, it is embedded in metadata, which becomes part of the page contents. So that's kind of where the XSS comes into play.
Yeah, and to be
So
clear, he doesn't actually discover the cross-site scripting. He discovers a open redirect,
yeah,
which, as he mentioned, it's in one of these meta tags. In particular, it's the open graph title property. He controls the content, and in particular, he can break out of the content. Can't do angle brackets, can't go like, full cross-site scripting, but he can break out the attribute and inject further attributes. So using that, inject the HTTP equivalent refresh tag there and set your content to have URL, and you get that redirect to happen. And I do agree, the write-up did seem a little bit unclear. Oh no, I didn't think it was too bad.
I think it was
Especially
just a bit of a
considering
language barrier, honestly.
Yeah,
That's all.
I'd say considering you probably hasn't written up to me, like it wasn't a bad, like I could follow it, I could understand what was going on there. On like some reports where there have been questions about what's even going on, like I got it. He got this. He got the redirect, reported it to Facebook as open redirect on that filter. Facebook, they came back and they bumped it up to a $25,000 bounty and gave it because it was a cross-site scripting on Instagram.com. And that's at that point we don't really know how Facebook escalated it. He makes the claim, or at least he says, I believe it happened by including the character set property and switching over to the IMAP4 modified UTF-7. UTF-7, it used to be like a really common trick for cross-site scripting, but changing over to UTF-7 or in this case IMAP4 modified UTF-7, changing over to that, as I know in Firefox that like UTF-7 on a whole, and that includes this IMAP4 modified version, is part of the not for browser list, which basically means it supports this character set, but you can't use it in the browser. You can't use it on like a page. It won't support it there. So I don't think his theory's right about how they got cross-site scripting. It might be, maybe he has more information than I do. I'd be curious how they transformed this one into cross-site scripting. So you're able to break out the attribute. You can't do any spaces. And there are some character restrictions, and obviously you can't actually break the tag. So if somebody wants to give that a shot and let us know kind of how they turn that into cross-site scripting, I'd be interested to know their trick, but I'm not sure it would be this character set. I believe Chrome also won't support UTF-7. I didn't go and validate that, but I know Firefox doesn't, and generally speaking, if Firefox isn't doing it, odds are Chrome also has the same security purpose there. Because I mean, like I said, UTF-7 was a common trick for getting around some of the character restrictions when it came to cross-site scripting.
So I think Facebook does deserve a bit of credit here for escalating it to a 25K bounty. They could have kept that part to themselves. They were cynical and skimped out and just paid him for the open redirect. But they didn't do that. They let him know that it was possible to take it further, and paid him out based on that instead of just his original report, which would have been lower impact. So I think Facebook should be credited a little bit there. I think that's cool on them. They didn't have to do that. So yeah,
I mean that's nice to see. I will also mention, just since I was talking about leveraging that into cross-site scripting, I am aware that you could use a data URI. But that will not execute. That'll execute in its own context and not as part of like inside Instagram.com. And since Facebook does say it's in Instagram.com, I would assume that they didn't just do a redirect to a data URI, that there was some other way of leveraging this. That said, maybe he is correct and that's all he did. They're just assuming like, wider support of browsers than what I might be considering. But yeah, I mean, I'm curious how that one was leveraged into full cross-site scripting from a meta tag.
We'll probably never know, at least not from Facebook. So there was another Instagram finding last week as well. This one was a code execution bug in the app itself on the Android and iOS devices. So this was found by the researchers at Checkpoint, which we've covered quite a bit before. They do some awesome research. Again, like we commonly see with these types of app exploits, it comes down to a bug in a library or a third-party dependency the app uses. In this case, MozJPEG, which is Mozilla's JPEG encoder. So the Checkpoint researchers decided to build a fuzzing setup to target MozJPEG because they noted that there were fuzzing setups already existing for kind of the precursor to MozJPEG, which was, I actually don't remember what it was called. Do you remember what it was called? Oh, libjpeg turbo. That was what kind of MozJPEG was based off of. So that was being fuzzed a lot, but there wasn't really a focus on MozJPEG. So that's where they kind of filled the gap and built the fuzzing setup there. And after running the fuzzing setup for one day, they ended up with 447 unique crashes. So after going through and triaging them and stuff, they found one that was worth investigating, which was an out-of-bounds write due to an integer overflow when they were parsing the JPEGs to read it. So the vulnerability itself is fairly straightforward from a code perspective. It's a classic integer overflow with the dimensions for the image, for the allocation of the image data, which I'm almost certain we saw that last year with Instagram too, or maybe it was Snapchat with GIFs.
Wasn't it WhatsApp?
Maybe it was WhatsApp, because WhatsApp is owned by Facebook too, right? Yeah, so yeah, they had an issue with GIF that was very similar. It was basically image dimensions, and it was an integer overflow issue if memory serves. So they dive into how they exploited this wild copy to get code execution, and how they exploited the gmalloc allocator, which I won't get into too much here. Basically, they find a kill switch through a struct member they can control to kill the copy early before it clobbers everything, which is basically the only way you can exploit a wild copy, because when you integer overflow, you're getting really large numbers for copies, and you have to kill that early somehow.
Yeah, I found how they dealt with this actually kind of interesting. So as you're saying, they've got this wrap malloc that they can basically overflow the size on, and oftentimes with this sort of overflow, it's going to try and copy a lot of data, as you were just saying. Like, you copy 4 gigabytes of data, odds are you don't have 4 gigs of data to actually copy into, so you're going to hit an unmapped page and you're just going to get a crash without actually getting it exploited. Just out of chat, we're asked, wasn't the WhatsApp issue a double free? There were actually a few WhatsApp issues. One of them was definitely a double free, but there have been other, and that was the most popular one. I think that's the one actually that was seen being exploited in the wild. That would have been late. That would have been like, what, about a year ago? I want to say November. Maybe I'm wrong about that, but so yeah, that there was a double free, but there have been other WhatsApp issues too that we've covered. Jumping back onto this one though, as I was saying, they had that challenge with the 4 gigabyte copy. So what was interesting in this case is that it wasn't actually copying everything all at once. It wasn't doing this giant 4 gig copy, or however big your overflow ended up being. It didn't do that. Rather, it would copy line by line, image line by line. So it's copying the image data, as you'd probably guess. So it's however many bits per color channel, however many color
Pixel
channels
depth,
of things. Yeah, pixel depth is the word I want. Pixel depth times the width of the image, and it would copy that, and then it would go forward and copy the next line and copy the next line. It would do that. So because of that, they actually had room to, as Spectre was saying, they found this sort of kill switch to stop the copy during it, or to stop during the copy. But what they end up finding, like, they also talk about kind of their setting the heap up to find what to copy. They find the function pointers in the CInfo structure, holds a bunch of function pointers and image metadata. It's in the stack. So they talk a little bit about how they structure things to get into there. But yeah, I did find that aspect interesting, that dealing with a large copy, because that is a frequent issue when you have to deal with these really large overflows that are still going to try and copy a lot of data, but you get the allocation to be small. So I did find that section of this to be interesting.
So what I think was cool here, and like as an important takeaway, was the beginning part where they talk about how they made a fuzzing harness. Because basically, I think they used like AFL and they just wrote a harness around, the image format, which is one of the cool things you can do with AFL is that ease of setting up harnesses. That's kind of what it provides. So I think that is an important key takeaway is the fact that they set up that fuzzing setup and they found 447 unique issues. So this issue obviously was fixed, but the fact that there's so many more issues means there's probably a bug farm here. There's probably more issues out there that could be exploited to the same potential, maybe even easier to exploit, because I doubt they were able to triage all of their findings, and obviously if they found that many, there's more that they hadn't discovered at that point.
Yeah, I guess it is worth kind of getting to the spoiler of this one, which is nicely at the end they present the fact that they couldn't actually exploit this issue, at least not on Instagram, and that's because Instagram would transform all the images they get into RGBA, which is like the byte for red, byte for green, byte for blue, and byte for L for transparency.
So it's RGB32 or ARGB32, because there are different formats too with that.
Yeah,
like
so
you can
it's
get
RGBA. So
okay,
like that.
No, because I know with colors you can get pixel formats that are like they use like 2 bits for red and 2 bits for green and 3 bits for blue or whatever. So like I know sometimes the amount of bits and stuff that go towards it can be different.
No, it's the 32-bit.
Okay.
But the problem here, why that's a problem, is because of course now they're translating a lot of the colors over. The alpha, basically in their conversion, they end up with the alpha always as 0xFF. Which means that any address, because they don't really control their offsets, or how can I specify that? They don't control every byte of the result because of that conversion that Facebook actually does.
Yeah, they lose control over some of the bits.
Yeah, so they always had that 0xFF as part of the address, which ends up sitting in kernel memory. So they can't actually redirect to to something useful because they're running in userland. Which is kind of because they do mention if this were if they switch the endian on the system, then they would be able to, because it would be writing the least significant instead of the most significant bits with FF as it was reading it in. That said, they weren't able to actually exploit it because of Instagram basically converting the images.
So I do have a bit of a question there, because usually when you're talking about like a 64-bit environment, if you're only dealing with a 32-bit integer or a 32-bit address, that 32-bit address should always be in userland, because with a 64-bit address space, the kernel boundary is usually defined by the upper 32 bits. It's usually the second highest byte, I want to say.
Remember though, RGBA, there's more than just the 1 byte.
Well, I'm talking about,
I guess RGBA is only it's only 32 bits. Yeah.
So that's where I'm kind of confused, is where in a 64-bit address space, that should still be a userland address. Although, so maybe they're talking about hitting 32-bit devices?
Well, no. I don't know. So if you let's assume you have 4 of those 32-bit ints. It's still going to start with that FF.
If they're grouped together, yeah.
Well, they're going to be grouped together because that's the image format.
Yeah. Okay, I see now.
So that makes sense. Every byte's like that. Yeah.
Yeah. So you will always end up in the kernel canonical addresses. Okay, yeah, that makes sense.
Their mention is that we lost our quick win. One lesson we can learn is that this is real life and not a CTF game. Sometimes one crucial const value set by a developer can ruin everything. And yeah, in particular, this thing would set that alpha to 0xFF, basically regardless of what the original was. I guess I haven't quite made that clear, but that's part of its conversion there.
You're not always going to come out a winner. I guess that's the moral of the story.
No, but it was definitely still an interesting read, too. Like I said, how they dealt with some of the issues, and I mean, didn't end up working out, but yeah.
Oh, for sure. I mean, I think this is one blog post where it's probably a good reference point and starting point for people who want to find issues and want to find somewhere to start looking for issues. Because it's not just an exploit post. They don't just go into the specifics of the bug detail and the exploit. They do, but they also go into the background information. It's kind of more like a research post. There's a lot more to take away than there is in like your average exploit write-up. So I think that's where this post really provides some value, especially in that first half, talking about the fuzzing and stuff. I think that had some good insightful information in there.
Although it is worth pointing out also that this is an issue in an image, which means it's a parser issue, which means that you don't have the ability to go and like figure out what address something is at. So ASLR is a bigger issue when it comes to trying to exploit something like this. And they don't talk about it at all. Which is fair, but go ahead.
I was just going to say they do also leave some recommendations on that point. Basically just saying that they should limit, like Facebook should limit the attack surface by restricting the receiver to a small number of image formats. Like they shouldn't allow, a bunch of different types of image formats to try to limit the attack surface down a bit more. So that's just something I kind of thought about when you were talking about the, the fact that it was a parser bug. So I think we can move on to our kernel exploit. So, we have to have one. I think every episode. I think we've had like 4 or 5 in a row now. I don't know. I might be wrong on that, but we've definitely been going hard on the kernel train. So this one is kind of it's a bit of a rare treat because it's usually when we're talking about kernel exploits, it's Linux or it's BSD or Android stuff. This one is actually in a Windows kernel driver. It's in the MSI Ambient Link driver. And Ambient Link is basically used for creating ambient lighting that syncs with in-game stuff. So if you've ever seen like a true gamer setup with wall tiles that light up depending on what's happening in the game and stuff, that's basically what Ambient Link facilitates. It's stuff like that makes that happen. So the post goes into some background on Windows drivers and how they're structured, and how to figure out what's hittable from an unprivileged user and checking the discretionary access control lists. Because, with Windows, you do have a little bit more complex of a security model than you do with like Linux or something like that. With Linux, it's basically just chmod. If you can read and write the device and you're in an accessible group to that device, you can access it. Whereas Windows has like discretion, the DACs and stuff like that. So, they go into that to go into some background on how to figure out if it's even worth looking at that driver. And after verifying that the driver was accessible from a low integrity process, they jump into the most interesting and well-known entry point of drivers ever, ioctls. So as you can probably guess by the fact that they talk about ioctls and the fact that this is a CVE, this bug was discovered in one of the commands the driver accepted. It was quickly found by basically using a very quickly written dumb fuzzer, which they do actually link to in the post. They have I think it's a git paste. So, you can kind of take a look at that and see what their fuzzer does. It's nothing super complex. It's not like a coverage guided, monolithic giant or anything. But basically the issue is a fairly trivial Stack Overflow, which you could abuse to get PC control. It doesn't even look like there were stack cookies being used here, which I thought was a little bit surprising. I thought Windows kernel drivers generally, they had stack cookies, or maybe they do, and this specific case was just missed by the compiler or something. But the post does go into further details of how to take PC control all the way to code execution, which is kind of notable because when you get to kernel, PC control definitely isn't the end, especially on the newer Windows like Windows 10. You have mitigations like supervisor mode access prevention, supervisor mode execution prevention. You've got patch guard. And basically, they talk about how they got around those mitigations, using ROP gadgets to disable the SMAP bit and then jump into shellcode, which is in the CR4 control register, which should be caught by PatchGuard because PatchGuard does monitor control registers, but they kind of talk about how they can erase that. But they weren't able to exploit it on the latest Windows. They weren't able to hit Windows 2004. But the issue itself is a little bit hard to dig into because they are attacking this from a black box perspective. They're not doing it from a source code perspective, which is also something that's kind of interesting and that we don't really see too often either.
Yeah, I mean, I thought the addition of kind of how they weaponize the exploit in terms of the kernel mitigations, I found that to be an interesting part of this write-up. I felt like a lot of it, though, like they say too much. Like they spend a lot of time on stuff they probably don't need to say. It's not a very concise write-up. And it's not just in the sense of having background. Like I pulled up a paragraph here. This Windows 7 paragraph. Like they could probably write this in like a third the space. Like you can probably get rid of the first two paragraphs almost completely, taking like a sentence from them. Things like that. So
it's a little bit rambly, yeah.
Yeah, it's like this entire section there is basically only to mention the fact they did the jump, or they create an infinite loop by jumping 0. Like that's what this entire thing's for. So it goes on a little long, but I did find it useful to see and the coverage there. There's nothing groundbreaking here. Like there's nothing that's like their own new technique or something. It just comes off, at least in the Windows 10 area, like a little bit of a overview over how they dealt with some of the mitigations, which, like I said, it's not groundbreaking, it's nothing new, but it is useful to see and kind of have it laid out, because if you don't know what to look for, you don't necessarily know that people have already found ways around most of these things.
Yeah, so I mean, unfortunately, when you're talking about kernel issues, a lot of write-ups and stuff that you see that talk about kernel bugs, when it gets to the more modern mitigations like SMAP and stuff like that, they basically just kind of wave it off. They hand wave it and say, we're not going to talk about how you bypass that. That's kind of left as an exercise to the reader, which, I mean, this is basically another reference point to add for people who want to know how those types of mitigations are bypassed. Because unfortunately, even though SMAP has been around for a little while now, there's really not a ton of resources to talk about getting around it because, well, mostly because it is pretty difficult to get around a lot of the time, honestly. You either have to use a trick like they did, which is using ROP or JOP to flip the bit in the control register, which won't always fly. Or the other way you have to do it is, especially like with some bug classes, that's not even a viable attack strategy and it becomes a lot more difficult. You have to usually chain another bug entirely to be able to get around it. So because of that reason, you don't really find a lot of, write-ups and stuff that go into detail on bypassing those mitigations. So it's cool to see that here. Another point I think that this article brings up is yet another testament to how dumb fuzzing can be effective even today. They literally found this issue in like a Python script fuzzer that they wrote up that's like less than like 50 lines of code. So just shows how unreasonably effective dumb fuzzing can still be.
Yeah, I mean, to be fair, they also knew that the vulnerability existed in the ioctl. Like the CV report actually contained, because they didn't find the original CV. This is just them looking at it.
Okay, fair enough. I thought they actually did find the issue through the fuzzer and then later confirmed that it was already like found, but okay. I might have misread there.
I'll double check here, but I believe they make mention, because they even mention like that that they know these things, but we're going to approach it from, this vulnerability is based on the one discovered by Core Security.
Okay, fair enough. So, moving on to one of our headlining topics, bypassing Android EM. So, Arun's blog post talks about mobile device management for Android, which allows it basically provides a remote solution to restrict the device. It allows an entity to basically have greater access than a physical user would. So somewhere you might see this as like a corporate issued phone, right? If they have proprietary apps and code running on that device, they probably want to restrict the user from doing anything that could compromise the integrity of that application. They probably don't want the user to be able to root the phone and, dump the app or anything like that, for example.
Yeah, so the other thing there where it would be used is like having certain certificates on the device to identify it, to know it's in a know it's one of their like issued devices or trustable device. That's another place where MDM comes into play.
Yeah, that's another good point. So there's some things that MDM restricts to try to facilitate that. They lock developer mode, they lock factory reset, they lock the bootloader, and they do some other things as well. What makes this blog post really fun, though, is not only do they talk about bypassing MDM to perform some of those restricted actions, but it's using electromagnetic glitching or fault injection. So when it comes to glitching, you have a lot of potential attack strategies you can go for, but typically they're grouped under two classes. You have invasive attacks and non-invasive. So invasive basically means it's potentially destructive. If somebody looks at the device, they can see that it's been tampered with. If you use like a heat gun or something on a chip, and like the chip has obvious damage on it, that's something that would be like an invasive attack. And those types of attacks are typically harder to perform. They're a lot riskier. But then you also have non-invasive attacks. So non-invasive attacks mean the device is not permanently altered. There's no like trace evidence left behind. And electromagnetic fault injection is an example of a non-invasive attack. So that's as opposed to, say, like delayering a chip or microprobing or something like that. That would be like more of an invasive kind of attack. So they basically abuse the inductor in a voltage boosting circuit on a gas lighter, which they say is $1.50. And they basically use that to create an electromagnetic generator. And the glitch they performed, it's kind of interesting because usually when you're talking about a glitch, you're trying to do a precise attack on like a specific instruction or function or something. Here, they basically just use the glitch to induce a kernel panic. And when the kernel crashes, they have a debugging backdoor trap to allow debugging via the PC, which then allowed them to just straight up flash the firmware. You could read eMMC, which is the embedded multimedia controller. You could change the SoC configurations, which is what allowed them to bypass MDM. So it is a little bit weird in that, they didn't have to do a precise glitch attack to get to their end goal. They didn't have to bypass a specific check or anything like that. So this probably means that any kernel DOS would have facilitated this, that a glitch attack probably wasn't required. But I love hardware fault injection and glitch attacks. I think they're so interesting and magical in a way, because computers are deterministic. They are supposed to follow the instructions they're given, unless you mess with the hardware from the outside, and that's why I think they're so cool. And this blog post kind of shows like a real world application of where glitching can be useful and why physical attackers sometimes need to be considered in the threat model.
Yeah, I thought it was interesting. Just I don't do anything with like this hardware hacking. So just seeing how, in a sense, simply he was able to DIY this sort of EM fault injector. That said, I mean, this isn't. It's as an MDM bypass. I don't know if it lets you disable it, but it's through reflashing the phone. So you're kind of left like, yes, you're getting around that, but you're not. Like the reason I mentioned like the device keys and stuff being there is because when you reflash it, this is no longer going to be seen as a trusted device. So if it was, you can't like use it to get onto like the corporate network or something anymore if it was being used that way. So like it works, and there's absolutely cases like I could imagine this being useful, say on something like a kid gets a laptop through like one of those or I guess I'm trying to think if they actually run Android or not, but like those Google Chrome devices or whatever.
The Chromebooks you're thinking
Yeah.
of? I think they run their own. I think they call it Chrome OS. I don't think it runs Android. So
and then there's Fuchsia or whatever too with that. Either way, I was thinking like it could be used that case, or maybe your company just gives you a phone and they're using that to protect it. Like, okay, you can kind of do that and you can like resell it or something. Like it has its use. I'm not saying there's no use to this whatsoever. It's just if you're wanting to bypass MDM, you usually want to keep some of the other aspects of it. Like you just want to disable certain features of it. So this is like a brute force on it. I mean, it's not a brute force attack, but it's a hammer rather than a scalpel.
That's a good way of putting it. So I really like this blog post because of the approach they took with the hardware stuff, and the fact that it's a lot more understandable for people who aren't super familiar with hardware glitching already, because a lot of the complexity when you're talking about glitch attacks comes down to that timing nature, right? Like if you're pulling off a voltage glitch or a clock glitch, you have to do it at the instruction, like at the CPU level when it reaches the instruction you want to hit. That gets super, super complicated, and that's when you get into things like using FPGAs and all this crazy stuff that most people like probably haven't even really heard of. But where this glitch attack is basically just get the phone to crash. That's a pretty reasonable, end goal for a relatively like simple, non-invasive glitch. So yeah, this kind of gives like a peek into the window of the crazy realm that is, hardware attacks. So that's where I really like this blog post.
Yeah, it is worth knowing. Like they did want to avoid any hard fault that would actually cause the phone to reboot. So it wasn't just like any crash whatsoever, but
yeah,
still pretty open.
Yeah, that's fair. I did neglect to mention that. It was a little bit, but it wasn't like super precise. So getting into our research topics, we have more XSS stuff. This one dives deep into XSS, or more accurately, heavily restricted XSS with a restricted character set, basically, and side channeling with XSS. So this was like pretty. I don't know if I've ever really seen XSS taken to this degree of like a complex attack and using side channels and stuff. Like I never would have dreamed of this kind of attack, but it seems pretty interesting, and I know you found it interesting, Z. I'll let you carry away with it.
Yeah, I mean, it reminds me of like you'd see this sort of side channel being used with like CSS injections rather than cross-site scripting. That's in this case, what happened here was Portswigger, and we've talked about these before. They have their Impossible XSS labs, which are labs that there's something wrong with the code in all of them. In this case, it's a pretty heavy character restriction. And it's being injected into a single quoted JavaScript string. So you're already in the JavaScript, but you can't use semicolons. You can't even use quotes. You can use a single quote, so you can break out of the string. So the character restrictions are basically your letters, numbers, backtick, single quote, and plus and dot or period. Those are the only characters you could use. So as we mentioned, you can break out of the quote, but from there, how do you get your cross-site scripting? Now, what was interesting with this one is they specified just calling alert wasn't going to be sufficient. They want you to actually exfiltrate the document.cookie or some actual value to consider this one solved. And that's where the blog post author kind of went and took it. Rather than focusing on getting this arbitrary JavaScript injection in there, cross-site scripting, he focused on how can he exfiltrate that cookie. So he talks a little bit about some of it, but ultimately it did come down, or he talks about like what you could do. You break out with the single quote plus whatever variable you want. You can kind of start getting some information into the variable there. Plays around with a lot of things, talks about the side channeling through. And to be clear, I'm only giving an overview of this. I'm not going to dive into everything, but turning into an oracle, he started off by using like performance. So using a really large string, splitting it on one of the characters, and seeing how long it takes for the frame to load. So you can iframe that page and you can see, okay, that loaded in a really long time. That meant the character's there. Loaded really quickly. Probably not there. And by really quickly, it still might have taken a little while, but you can tell the difference in the time. The problem with that is not necessarily going to be able to split on every character, so kind of deals with that. I actually learned one trick here about using the backticks. So you can kind of call your function, then rather than doing brackets for providing an argument, you can just do backticks, and you can provide a single string argument. I didn't know about that. I
don't know why you would need that, to be fair.
Yeah, I think I've
Seems like a
seen
weird
it before.
thing to support.
Yeah, I'm not sure what the origin of that would be either. I think I've seen it used before and just didn't think much of it. Like, didn't really notice that it was being used that way. Either way, he did this timing-based one, and then he kind of worked it out a little bit more. Goes into some JavaScript details in terms of trying to stop the execution a little bit quicker, things like that. Really interesting write-up, and I think a lot of Portswigger's work is interesting. Like, they've been doing a really good job with their research that I've been following in the last couple years. This is just one from, I mean, they take it pretty deep, and I mean, like I said, it was something that was initially thought of as being a impossible cross-site scripting. They do mention, looking at this timing, it is similar to, like, you know, a known cross-site leak technique, like, because that is ultimately what they're doing. But yeah, oh no, I found it to be some interesting research.
Yeah, it's funny because the first attack, especially when you're talking about like timing attacks, because that's essentially what it is. It's basically a timing side channel attack. Usually, when you see that type of attack being used, it's against the crypto system. It's checking, you know, it's trying to derive information about the key based on how it's being used to encrypt something or decrypt something. I never really thought about how it could be used in like an XSS context to exfil a cookie. So, I mean, that's kind of cool. It kind of shows you that, you know, tricks can kind of port over to other areas, even if you don't think that it would really be useful there.
The side channels on a whole, like using the timing trick there, is like they do mention here, it comes out with like an XS leak technique. Cross-site leaking, relatively new. I want to say that was last year at some point. Somebody mentioned like they were able to leak like some Project Zero bug reports, like knowing that they exist, and you can leak some information out from that. I think was kind of the one that at least made circles that I saw. There might have been some other cases too, but yeah, like that type of side channel is, oh no, I want to say it's becoming more popular, but I haven't really seen a lot of reports about it lately. But I mean, like the side channels, like it's definitely something to pay attention to. Like it's an interesting area that maybe isn't getting as much attention as it should. I know right after the initial reports, it definitely was, but I haven't seen a lot now. So either everybody's dealt with it, which I find kind of unlikely, or maybe people just aren't quite looking for it as much or not paying out on it.
So their attack strategies use iframes, right? And they, like, especially for the second attack, they track if the load event stopped via cross origin on an iframe, which they don't really mention it here, but I'm assuming that means that this kind of attack wouldn't work if they were using same origin policy, right? If they were using SOP, then this attack is
same
dead.
origin policy is going to be in place pretty much by default. That said, chat, isn't Chrome's new same site default preventing the cross-site leaks? And you might be right about that, actually. I don't do the bounty hunting, so yeah, it might just be that the same site being introduced now is preventing them.
Yeah. So I think with that said, we'll move on to our last topic, or our last research topic at least, which is security things in Linux v5.7. So this was put out on September 21st by the person who loves Linux security from a defense standpoint the most, Keys Cooks. So, you know, he does these basically for every like minor and major Linux kernel version that's put out there. You know, just a summary of some of the newer things that are landing when it comes to security in the kernel.
Although the kernel is maybe progressing a little bit quickly because we're currently on RC7 of 5.9. So 5.8's already done.
Yeah, I've been noticing that too lately. There's so many more like quicker minor version updates in V5 than there was, say, in like V3 or anything like that. Like if you look at the time gap between V2 and V3 and like V3 and V4, and then look at like V4 to V5 and the V5 minors, it's pretty insane how much it's kind of ramped up over the last couple of years.
They're on like the 6-week release schedule, I think.
Yeah. So the major, kind of headlining thing in here is probably the ARM64 pointer authentication support. So PAC has been around for a little while. iOS has been using it for over a year now, I want to say. But iOS was kind of the first adopter, right? It's still not really supported in Android. They've been trying to add it to Android forever. But it's been hard to, like, they've been trying to add it in the user land, and it's just the way they launch processes makes it difficult to implement. I can't remember the exact specifics of that, but there is threads you can find on that in like the Android development forums and stuff like that. But yeah, so pointer authentication is a decently strong mitigation. It obviously has been bypassed, but it's certainly not easy to bypass. So that is kind of a scary one. That being said, it is only affecting ARM64 because this kind of mitigation does require support from the hardware. So you're not going to be seeing pointer authentication coming to like x86 anytime soon. I don't think there's even anything in the works from Intel's side to be able to match what pointer authentication does.
Doesn't CH have something with memory taking that you could, in theory, use for?
Now that I think about it, Intel, I think there is something like that. Yeah, but I think it's only on certain processors.
Yeah, no, it's not widespread yet at all. Like CH isn't really widespread, but CH has been Intel's pushing of like that's also where you get the hardware shadow stack. I think you get some CFG out of it. There's a few different features.
Is that CH Intel. Or CET?
I think I was saying CH, but I think you're right. It might be.
Yeah, control flow enforcement technology. Yeah, CET.
Yeah, my bad. Yeah. I'm obviously thinking of the certified ethical hacker. But I mean, Intel's been doing some work on that front, is what I'm getting at. It's definitely not widespread yet. I do think, memory tagging is coming.
Oh, definitely, yeah.
Like, it's clear that we're getting memory tagging. Maybe we're not going to have it right now, but it's coming.
I think probably, I'd say within the next 5 years, it's reasonable for seeing memory tagging. That being said, memory
widespread yet on desktop, but like I think Android for sure will definitely get it by then. Like, as you're saying, they're having some issues, but they're working on it.
Yeah, I mean, Android is probably going to be the next adopter of the control flow stuff because, Androids are running ARC64. They're running ARM64. They're not running x86, obviously.
Yeah.
And ARM seems to be like the leader when it comes to ISAs that are kind of taking charge on the security mitigation front. Like, I can't think of any x86 hardware enforced mitigations that have come about in like, I don't know, I almost want to say like 10, 20 years. Like,
like we were just mentioning the CET stuff.
They're working on it, but I mean, they don't really have anything, whereas ARM already has PAC out, right? So that's where I'm kind of saying, ARM Windows is kind of leading that charge.
The hardware support now for shadow stacks out. But yeah, no, I do agree. Like, ARM has kind of been pushing the boundaries on that. I mean, that goes actually quite a ways back, with like the Cherry stuff.
Yeah. So there are some other things in here that aren't just the pointer authentication. They mentioned free list obfuscation to hide the free list, basically trying to prevent it from being hit by like an arbitrary write or something to, be able to get control over any piece of memory you wanted. Structures are being converted to use flexible arrays, which I'm surprised I haven't really heard or seen flexible arrays, but apparently they're fairly recent to the C standard. And they basically use that for index bounds checking at compile time. And they also recommend using UBSAN for runtime checking, although you probably wouldn't run that in production. That's probably more of a, usually the sanitizers you run on debug builds. They mentioned some other things like replacing SNPrintf with SCNPrintf, which is like a new primitive they built up. just to avoid overflows when building up a string. There's a few other ones scattered in there, but I think ARM64 pointer authentication is probably you know, the biggest one, the one that kind of jumps out at you.
Yeah, pointer auth, I think, is definitely the big one to notice. I do think the bounce checking kind of matters, and just in terms of like code smells and stuff. Because once they have that, it'll be easier to kind of detect some of the areas where they are doing incorrect bounce checking. Whereas right now they basically just ignore that because there's so many places where those warnings are worthless. I did find that using Berkeley Packet Filter for the Linux security module stuff, like an API, so basically you can implement some of those security modules in BPF or using BPF. Found that interesting just because that does kind of create a little bit more of a dynamic ability to do the security policies. And those security policies can be pretty tough to deal with. It's just a lot of people don't tend to use them, like AppArmor.
Yeah, I think Android uses SE Linux by default, but I doubt many systems outside of Android are running it, for example.
Yeah, but I mean, they can be pretty tough, and that might increase adoption a little bit. It definitely takes a very security conscious user to start setting those up, though. So it's not necessarily a worry for exploit dev, but I don't know, it's something. I thought it was noteworthy, and obviously so did the author here.
So, what this post is kind of showing is just, security is becoming more and more of a focus when it comes to the kernel. For a while it was kind of neglected. I don't think people really cared. Linus was kind of against. He had a hard stance against like mitigations. At least at one point. I think he's kind of had to fall back on that a little bit because things have just been ramping up so much in the area of security for Linux. For the Linux kernel.
If you write code without bugs, you don't need the mitigations.
Just write good code.
Right? Exactly. Or it's to live by.
So we will wrap up the show with talking about our one shout out today. This is Code Review 101. I saw this being mentioned on Twitter. And this is a blog post that talks about tricks and techniques you can use when code reviewing to find vulnerabilities. It has a strong web focus, but these tricks are definitely, at least some of them, are transferable to other areas like binary and app research. To those who do code review a lot, these points are probably things you're already aware of. There's nothing earth-shattering in this post, but if you're new to vuln research, then this is probably a good post to check out. And why I say that is it highlights some things that beginners might not consider. Some of the things we've talked about before on the podcast. Basically, fixes aren't perfect. It mentions, looking at patches, previous fixes, the importance of developer comments and how helpful they can be. I feel like sometimes those are overlooked. They're not really considered as much. And using tools like grep and keyword searching to your advantage. One thing I will say, most of these do assume you have source code access, which, I mean, it is called code review, so fair enough. Which, in the case of web, you probably will have if you're pen testing. But if you're talking about binary and stuff, if you're doing like black box or gray box, reversing or something like that, then these tips might not be as, useful.
I mean, I'm not sure I'd agree with you that if you're doing web, you're going to have source.
Well, I mean, if you're like a official pen tester and you're hitting an app,
usually don't necessarily get the app code because they're usually still coming at it from the attacker perspective. You might have like the security engineers, like some of the internal team very well may have source code. Generally, that's not really pen testing. That's more of an application security thing. Pen testing being a bit more coming at from a network security perspective. That said, like there are people that do the code reviews. Like it's definitely, part of the job for some people. Like, I've done a ton of code reviews, and that's where I don't entirely agree with some of the advice. Like there's nothing here that like I'd say, oh, that's just terrible advice. Some of it though, like it talks here going at, follow the user input. as one way to kind of approach, like, go through, look at the code, find the code that processes user input, and then start following it through. I
Source to sync.
don't really like that approach a lot of the time, because in most applications, you're just going to end up with, unless you're looking at, so with some web apps, like if you're looking at it as like looking at how it handles this specific URL parameter, okay, like that could work. But if you're looking at like in a larger application, you often end up having just so many branching attack surfaces, like you just can't follow through all of it. So I tend to try and look the other way, find interesting areas of code and look how it's called, look the cross references to it. I mean, it's not like you can't do the follow user input. I just tend to take a little bit of a different approach on that. That way, like by looking how something's called, you also kind of have more of a chance to spot those second order types of issues. So if it's loading something out of the database, might not be really clear that it's user input, but you'll know what the value is and the value that you want to control.
So I guess what you're kind of getting at there is the controversial, sync to source versus source to sync debate. Which I mean, I that's fair. I think there's probably some points that probably go in the other direction too.
There absolutely is. Like I was going to keep going and say, like I see following user input a lot more useful as like your startup stage, where you're not actually looking for issues. You're looking to understand the code base as a whole.
Like mapping
that
out the attack
gets
surface.
you a lot more or better understanding of the entire architecture. And I mean, I don't think it's necessarily a controversy over going source to sync or sync to source.
I think there's a bit of a debate around it, but we could table that for another time if we.
Both of them have their place. I'd say that like both approaches have their place. Don't only do one approach. It's just like my kind of advice there wouldn't be following the user input to find the vulnerabilities, but more to get an understanding of the entire flow. But that does have its place. That is something that you should do. When it comes to what to look for, that's where it kind of definitely gets web focused, as you were saying. Nothing wrong there. I mean, especially the comments are a big source. I like to use comments or really just any of the keyword searches. I like to use them more to find the area or modules code to focus in on, rather than using it to find the actual vulnerabilities. So they give the example here of when they're talking about using grep, looking for like input and eval. I might look for some less dangerous functions just to find the area of code something's being done in. Either way, I don't want to critique this. Like it is still solid advice. I don't want to sit here and be like, I do this all differently. I just want to share a couple of thoughts there, but I mean, it's not bad.
Yeah, I mean, that is a fair point regarding with pen testing, not assuming that they all have source code. So, I mean, yeah, I kind of misspoke there. That's my bad. But basically, to summarize it, I think there's a lot of stuff here that may seem obvious or well known to people who do a lot of code review, but I think that might just be an assumption that's easily made by people who do it a lot. They might not; these kinds of points might not be so obvious to a beginner. So that's kind of why I wanted to shed it out a little bit.
Yeah, and it's all a fair starting place.
Exactly.
Like, for anything that I've said as a critique, like it's not like any of this is bad advice.
Yeah.
Like I'm not trying to hate on it or anything for that. Just as you get experience with code reviews, you'll find yourself kind of coming up with your own flow and way to do it. Everybody tends to do it differently. I have my own opinions. They have theirs.
Yep. So that kind of wraps up this episode. I'd like to thank everyone for tuning in. You can catch the VODs on Twitch or on YouTube 24 hours after the stream. We have previous podcasts up on Spotify, Apple Podcasts, Google Podcasts, and more links on Anchor as well. Keep a lookout for our discussion video, which is coming on Thursday. And that'll be on like YouTube. I said, we're doing those bi-weekly. Yep, that will be on YouTube as well. You can join our Discord if you want to get involved with the community. Follow us on Twitter. But yeah, other than that, check out our discussion video on Thursday, and we will be back again next Monday at the same time, 3 p.m. Eastern, 12 p.m. Pacific, and we will see you guys then.